Imagine for a moment a giant spinning top on the surface of the ocean. But instead of a toy, this spinning force is made up of swirling clouds, powerful winds, and an immense amount of energy. It stretches for hundreds of kilometers, and its power can be felt far and wide. This is the awe-inspiring phenomenon we call a cyclone. That's basically what a cyclone is. It's a massive rotating storm system that forms over warm ocean waters. At its heart is a calm, clear area known as the eye, surrounded by a wall of towering clouds where the most intense weather happens. The entire system spins rapidly, driven by the Earth's rotation and the heat from the ocean below. It's a powerful storm with strong winds that swirl around a center point. These winds can reach speeds of over 200 kilometers per hour in the most severe cyclones, tearing through anything in their path. The swirling motion is caused by the way warm, moist air rises from the ocean, cools, and then sinks back down, creating a continuous cycle of energy. These winds can blow incredibly fast, causing a lot of damage, honestly. Cyclones can uproot trees, destroy buildings, and flood entire communities with heavy rain and storm surges. The aftermath often leaves people without homes, power, or clean water, and recovery can take months or even years. Cyclones usually form over warm ocean waters and bring heavy rain along with those strong winds. The warm water acts as fuel, providing the energy needed for the storm to grow and intensify. As the cyclone moves, it can travel hundreds or even thousands of kilometers, affecting multiple countries and millions of people along its path. They're actually a natural part of our planet's weather system. Cyclones have been occurring for millions of years, shaping coastlines and influencing weather patterns across the globe. Scientists study them closely to better understand how our climate works and to improve our ability to predict and prepare for these powerful storms. You can think of them like giant engines that move heat and energy all around the Earth. By transferring warm air from the tropics toward the poles, cyclones help balance the planet's temperature. This movement of heat is essential for maintaining the climate systems that support life on Earth. And while they can be really dangerous, they also play a pretty important role in keeping our planet's climate in balance. In some regions, the rain brought by cyclones is vital for replenishing water supplies and supporting agriculture. So, even though cyclones can be destructive, they are also a reminder of the incredible power and complexity of nature, and the delicate balance that keeps our world thriving. Cyclones don't just appear out of nowhere. Their creation is a fascinating process that begins long before we ever see those swirling clouds on the weather radar. In fact, the birth of a cyclone is a story of energy, heat, and the powerful forces of nature coming together in just the right way. They're actually born over warm ocean waters near the equator where the sun's rays are most intense. Here, the ocean acts like a giant battery, soaking up heat from the sun day after day. The water temperature needs to be at least 26 degrees Celsius, or about 79 degrees Fahrenheit, for a cyclone to even have a chance to form. This warmth is the fuel that powers the entire system. So what happens is, warm, moist air rises from the ocean's surface. As the sun heats the water, it causes the surface to evaporate, sending invisible water vapor up into the atmosphere. This rising air is packed with moisture and energy, and it begins to climb higher and higher, creating invisible columns of humid air. This rising air creates an area of low pressure below it. Think of it like a giant vacuum. When the air moves up, it leaves behind a space that needs to be filled. The pressure at the surface drops, and this low-pressure zone becomes the heart of the developing storm. Then, more warm, moist air rushes in to fill that low-pressure area. The surrounding air, which is also warm and full of moisture, is drawn in from all directions. As it moves toward the center, it picks up speed, feeding even more energy into the system. This cycle of rising and incoming air keeps repeating, making the storm stronger and more organized. As this air rises and cools, it starts to form clouds and thunderstorms. The water vapor condenses into droplets, releasing even more heat into the atmosphere. This extra heat causes the air to rise even faster, building towering thunderclouds that can reach miles into the sky. These clouds are the first visible signs that a cyclone might be forming. And because of the spinning of the Earth, a force known as the Coriolis effect, the whole system starts to rotate. This rotation is what gives cyclones their iconic spiral shape. Over time, if conditions remain just right, This swirling mass of clouds and storms can grow into a powerful cyclone, capable of traveling thousands of miles and impacting everything in its path. That's how a cyclone is born, a breathtaking display of nature's power and complexity. Cyclones, also known as hurricanes or typhoons depending on where they form, are powerful storms that don't just appear anywhere on Earth. Instead, they form in very specific regions, and these areas are scattered across the globe. These regions are known as cyclone basins, and each basin has its own unique characteristics and weather patterns that make it suitable for cyclone formation. Cyclone basins are large areas of the ocean where the conditions are just right for these massive storms to develop and grow. The main ingredient is warm ocean water, usually at least 26 degrees Celsius or about 79 degrees Fahrenheit, which provides the energy cyclones need to form and intensify. But warm water alone isn't enough. The atmosphere above the ocean must also be moist, and there needs to be a certain amount of instability in the air to help thunderstorms develop. Another key factor is low wind shear, which means the winds at different heights in the atmosphere aren't changing too much in speed or direction. Wind shear is simply a term for how much the wind changes as you go higher up in the sky. If the wind changes too much, it can actually tear a developing cyclone apart before it has a chance to grow. Some of the most active and well-known cyclone basins are found in the North Atlantic Ocean, where hurricanes often threaten the Caribbean, the Gulf of Mexico, and the eastern coast of the United States. The Eastern Pacific Ocean is another hotspot, with storms frequently forming off the coast of Central America and Mexico. The Western Pacific Ocean is actually the most active basin in the world, producing more cyclones, called typhoons here, than any other region. These storms can impact countries like the Philippines, Japan, and China. Cyclones also form in the Indian Ocean, affecting countries such as India, Bangladesh, and parts of East Africa. The storms here can be especially dangerous due to the dense populations living along the coasts. And let's not forget the South Pacific Ocean, where cyclones can impact island nations like Fiji, Vanuatu, and Tonga. Each of these basins has its own cyclone season, but they all share the same basic recipe: warm water, moist air, and just the right atmospheric conditions to set these powerful storms in motion. A cyclone has some really distinct parts that all work together. Right at the center is the eye, which is actually a calm area of low pressure. Surrounding the eye is the eye wall, which is a ring of towering thunderstorms with the most intense winds and rain. Extending outward from the eye wall are these spiral bands of clouds and thunderstorms called rain bands. These rain bands can bring heavy rain and strong winds to places that are actually pretty far from the cyclone's center. Have you ever heard of hurricanes and typhoons? Well, they are actually the same thing as cyclones. The only difference is where they form. In the North Atlantic and Eastern Pacific, they are called hurricanes. In the Western Pacific, they are called typhoons. And in the South Pacific and Indian Ocean, they are simply called cyclones. They are all powerful rotating storms, just with different names. Scientists use amazing technology to track cyclones. Satellites in space keep a constant watch from above, sending back pictures and information about the storm's location, size, and strength. Weather balloons are released into the atmosphere to gather data about wind speed, temperature, and humidity. This information helps scientists predict the cyclone's path and intensity. They use this information to warn people in the storm's path. Cyclones can be very dangerous. Their strong winds can uproot trees, tear off roofs, and even knock down buildings. Heavy rainfall can cause widespread flooding, damaging homes, roads, and businesses. The storm surge, which is a rise in sea level caused by the cyclone's powerful winds, can be especially dangerous. It can inundate coastal areas, causing significant damage and loss of life. Cyclones are a serious threat to people and property. There have been many powerful cyclones throughout history. In 1970, the Bola cyclone struck Bangladesh, causing catastrophic damage and claiming the lives of hundreds of thousands of people. In 2005, Hurricane Katrina ravaged the Gulf Coast of the United States, leaving a trail of destruction in its wake. And in 2013, Typhoon Haiyan, one of the strongest cyclones ever recorded, devastated the Philippines. It's important to be prepared for a cyclone. During cyclone season, pay attention to weather reports and warnings from authorities. Have an emergency plan in place, including a safe place to go and a communication plan with your family. Prepare an emergency kit with essential supplies, such as water, non-perishable food, a first aid kit, a flashlight, and a battery-powered radio. If authorities issue an evacuation order, leave immediately and seek shelter in a safe location. Cyclones are powerful forces of nature, but we can prepare for them and work together to recover. By understanding the science behind cyclones, heeding warnings, and supporting each other, we can build resilient communities. After a cyclone, communities come together to help their neighbors in need. They offer support, share resources, and work tirelessly to rebuild their lives. These acts of kindness and solidarity remind us that even in the face of adversity, the human spirit can triumph.